All right. Now, what that brings us to, ladies and gentlemen, is estimating the true mean now. Because remember, the true mean, and it behaves the same way, but be careful about this. Okay, just going to go through this idea here. Mu is a true mean. Mu is a different parameter. It's not a proportion. Okay, mu is the mean. Mean is a summary. Like if I said to you, what percent of the class is at least 30? Well, that's a percent. I'd have to count successes out of the total. But if I said, what's the mean age? I would gather your ages and compute the mean. It's a different parameter. You see what I'm saying? That's mu. Well, it has a very similar format. You say, what's the format? It's a sample mean minus a margin of error for the lower bound value and a sample mean plus a margin of error. Where the margin of error here is given by this formula. And yes, this makes an assumption that sigma is known. It's a very, very bad assumption, but that's okay. And then this is going to be for large samples. A large sample, ladies and gentlemen, is anything above 30. Because we're going to look at this today for large samples and next time for small samples. So in the past, yes, it's the same thing. In the past, you needed the Z alpha over 2 with a Z distribution in the past, and you had the same format. You had to use this is the confidence levels, 99%, 95%, 90%. Those are typically what they ask you. And yes, in the past, you had to use a Z table. But, ladies and gentlemen, we're not going to use the past. We're going to use a TI. Okay? Now, I'm going to tell you guys now what you use. And it's going to be very simple. In the TI, Z interval. We're going to see this now. But we're going to have to go through this question. We've got to read it. Got to read it. So what do they say? A sample of what? 600 college students indicate it took them a mean of what? 6.5 years with a standard deviation of 1.8 years for a bachelor's degree. Okay? Pretty darn normal if you ask me, but okay. It's not where you start, it's where you what? End. Always remember that. Okay? And now what are they saying? Use the what? Use the 99% confidence level to do what? To estimate. And this is why I'm always reading it. The true mean. So this is where it's different. What are you estimating now? The true mean. It's not the true proportion. It's what? It's the true mean mu. So just like before, you say, what do? We take the what? Sample mean minus your error less than the true mean less than the sample mean plus your error. You're going to end up getting, again, a lower bound value, okay, for that estimate. And you're going to end up getting an upper bound value for that estimate, just like before. Okay? Bless you. But what do? Gather your sample information. What is it? When you read it, what are they saying? Sample size is what? 600. Good. What does the 6.5 represent? Sample mean. How do you know? It's a mean that came from the sample. They just told you. And then now you have a sample standard deviation, which is S. So I'm just going to say to you guys, write that down. N is 600. Sample mean is what? 6.5. Sample standard deviation is 1.8. What's your confidence level? Confidence level is what? 99.9, 99%. Now, what I do have to say, ladies and gentlemen, there's kind of a typo without going over this with great detail. You see the sample standard deviation? It's really the true standard deviation. Okay, sigma. That's a population standard deviation. So I just want to remark, there's kind of a real technical thing here. Okay? That in order to use Z interval, in order to do that, you have to know the population standard deviation, which is really a bad assumption. Okay? Anyway, you're going to see that in the TI. You say, what do you mean in the TI? So when we go to that TI, like we've been doing, right? TI. You go to stat again, tests, but now you go to Z interval. Where is Z interval at? Number 7. So technically in the book, they're going to say, hey, sigma is known. And notice this. So you go to stats. It's in stats. Good. It doesn't have S. It has sigma. So they assume sigma is known. The population standard deviation is known. Okay, what is it? 1.8. What's your sample mean? 6.5. What's the sample size? 600. What's the confidence level? 99. So you just have now 4 values here. So what do you guys end up getting here? What is this going to be? This is what? 6.307. Oh, 6.30. 6. Yeah, let's fix that. I don't know what it is. I think my 6.310 is less than mu, which is less than what? 6.689. Okay? And notice here you get the what? The lower value and the upper value for the mean. Did I write it down wrong? Oh, it's 1-1, yeah. It is 1-1. Yeah, I think I was just focusing on, yeah, it's 1-1. %. So here's the true mean now, but I want to make these notes here to remind you guys in these notes here that the way I wrote the example in terms of the language is not good. This assumes my standard deviation right in here. Let me find a nice color. Maybe pink. That's not pink. Pink. It assumes your standard deviation is known. Population standard deviation is known. So on that, there's a technicality here on it that the language should say sigma is known from past somehow that standard deviation. This is really sigma. So, in case you guys go see a tutor, they go, that Mr. Judge doesn't know what he's talking about. Sigma is known. Yeah, I'm kind of reminding people it's right in here. It's your sigma. It's known. So I should have wrote down sigma's known. Okay? But it's not. It's kind of unrealistic. You don't know sigma. In all honesty, you don't know that population consistency at all. Just to kind of throw that out there. And here's another example. Shows you what's wrong with the world. There's a lot wrong with the world, but okay. Here's another good example. What is it? What does this say? Yeah, do you guys know? Are celebrities worth a lot of money? They are. Why? This is obscene. This is obscene, ladies and gentlemen. What's the problem? Well, a sample of what? 65 celebrities. It's N, your sample size, right? Surveyed reported a mean net worth of $200 million. Ooh, what is that? That's a lot of money. So they took a sample of 65. They computed a sample mean. Okay. So this is a sample mean. And then they say with a standard deviation of 28.5. Okay, use the what? %95 confidence level to do what? Sorry. To estimate what? True mean. So there's more than 65 celebrities, I guess. And so this is estimating the true mean. All right, you guys okay with that? And so all I do is write down the information. So from the sample, we know what? Sample size is 65. The sample mean is, I'm going to put 200 million. I'm not going to put the real number there because it's going to be a lot of digits and it freaks people out. But I'm just going to say your answers are in millions. What's the sample standard deviation? 28.5 million. And then they want the 95% what? Confidence level. Is that right? Okay. Easy peasy lemon squeezy. Is that right? Okay. Now we transition, ladies and gentlemen. We transition to what? TI function. Right? In the TI now, what do we use? What do we use? Z what? Interval. Z interval. So you go to the TI and you say, okay, stat, test, go down to Z interval. Which one is that? Number what? 7. Keep it on stats. And like I said, you say, shouldn't that be S? Well, no, technically it's supposed to be a known. To use Z interval, you got to have a known standard deviation. Impossible to know it. So using the sample, which is going to be what? 28.5. Yes, that's in millions. Okay. What was the sample mean in millions? 200. What was the sample size? 65. Isn't that still large? Bigger than 30? What confidence level are they going to use? 0.95. Hit calculate. And there you go, ladies and gentlemen. What is the answer? 193.07 less than mu, which is less than 206 point what? 93. And if you want to think about that, ooh, that's a lot of money, ladies and gentlemen. Now, this is just doing an estimate, okay, on the overall celebrity's net worth if you were to take a census. You can't because it's too time consuming, too expensive. So, you estimate that true mean, and then this is good within what again? This has a 95% confidence level. And I'm going to talk about that confidence level idea again, just so you guys can be aware of what it means. Okay? So celebrities have between 193 and about $207 million. That's like the average. It's a lot of money. That's their net worth, meaning property values and bank account and any other investments. That's their net worth. They're worth a lot of money. I don't know why they are, but it tells you how wrong this world is. But maybe it's right. Why are they worth so much money? Because in theory, they generate that money. In theory. Because you pay to go see them. Whose fault is it? Our own. If you want to decrease their salary, don't go see them. Don't go to the Taylor Swift concert. Don't pay attention to Kim Kardashian. You know how much they have more than that. They have some of those Kardashians have over $1 billion. Why? Why do they have $1 billion? Man, isn't that kind of, does that make you think? Makes me think. Why do we pay Kim so much money? Anybody have an idea? Or what's the other one that makes a lot of money? The makeup one. There's a lot of Kardashians that do makeup. Is it Kylie? I think she has probably a lot of money too. So she may have the most, right? And you want to know something interesting? She never developed that makeup. Somebody else developed the makeup. I couldn't tell you. Don't know what. Well, I mean, what the deal is, they just use her for the essentially to say, hey, we're going to say this is your makeup. You're going to get a cut, and we're going to get, our share. So they go and they use the celebrities to, to generate revenue. It's not like she was around designing makeup. You guys know what I mean? I don't know. I don't know what to tell you guys. It kind of bothers me a little bit. Mm-hmm. So when you read this celebrity net worth, you're like, wow. That's what happens when I see this example. It's a lot of money for a celebrity to have, somewhere between $193 million and $207 million. That's the average. That's the typical. That's a summary of their net worth. I don't know. I don't know what to say. Like, what was that guy? If you ever look at him, though, you ever look at some of these guys? They look miserable. Like, what's that? What's the guy who was on that show? He was making a lot of money and he screwed it up. Man, what's his name? He's such a car wreck. What's that guy's name? He was on 2.5 Men. Charlie Sheen. Yeah, Charlie Sheen. He's a mess, isn't he? It's like, man, I just think, how could you mess that up? And he can. I don't know. I guess people can mess things up. I don't know. You think All he's got to do is act and say his lines and behave himself and just collect $200 million. You know what I mean? That's all he has to do. He has to mess it up. I don't know. I don't know what it is. Isn't that weird? There's something about it. Makes me think. Anyway. What do you guys think about this stuff? Is it impossible to do? Because I'm going to go to the assignment portion now. But I have to go to the assignment portion. I'll share with you guys what I'm doing.